Lecture 8 about risk management out of 10 lectures in the course. In the previous lectures, I told you that project management is about understanding what's going on in the project, what's going on with the scope, what's going on with the time, what's going on with the cost, with the communications, with the quality, and how we can put all these pieces together and see what's going to happen in the future. So we try to predict, try to forecast the future, and then inform all the parties who are interested to know what's going to be in their future when the project will be finished. We inform them and then get their reaction. So if they want to continue the project, we continue. If they don't want to continue, then we change something. So we propose to change the scope, the time, and so on and so forth. So in my understanding, that's my personal attitude to project management, is that the project manager has to have all the instruments configured in order to collect as much information as possible about the reality around him, around the project manager, and then use all the possible instruments to put this information into a prediction. But all of this was true except one thing. If we do everything like I just explained, we will only see the future according to the information we have in the past. So we will just know that our expectation is to complete 125 tasks, and then the project will be done. But most probably, in reality, it's not going to be 125. In reality, it's going to be a different number, which will happen in the future. So the future will not be as we expect it to be looking at the past. There's a lot of unknowns coming to us. There's a lot of things which we don't know. And we need to put this uncertainty into project management. We need to let the project manager to modify the plans, to modify the understanding of the reality according to the information about uncertainty. And before we start with the questions, I will highly strongly recommend you the book of Rita Mulcahy. I'm not sure how to pronounce the last name. I think Mulcahy, probably. So she wrote an extremely interesting book, in my opinion, and that book actually changed my understanding of project management. It is a book which prepares you for the exam if you want to pass the PMP exam to be the professionally recognizable project manager. Then you have to go to the to Project Management Institute, so called, and there they will give you the exam. You pass this exam spending about 3 hours sitting in the examination place and answering a lot of questions similar to the questions I ask you. You will answer all these questions, and then they will either give you this certification or they will not. And Rita wrote the book which prepares you for the certification. So she explains basically everything I'm telling you, the same. She also has 10 chapters in the book, and in each chapter she explains the certain area of project management, the scope management, type management, cost management, everything we discuss in the same exact order. But she's trying to prepare you for the examination. So she looks at the project management through the eyes of PMBOK questions and answers. But while she's doing that, she teaches a lot of proper knowledge about project management. So in my opinion, this book is much better than any other books you can get about agile project management, about software development project management. All of these books, they will only prepare you for the final ultimate knowledge. So if you really want to be a project manager, my recommendation is to stick to this particular book. You'll get everything from there. Unfortunately, Rita has passed away a few years ago. So this is the quote from the book. She says, when you have done risk management on the project, your project will go smoother and faster with significantly fewer complications because avoidable problems were solved before they happened. This is all about project management. In order to, well, actually, there are two goals of project management, as I understand it. First is to see the uncertainty into the future. So look into the future and see what's coming and predict what's coming. And then the second part is to prepare yourself for what's coming. That's what basically project management is about. To understand what's coming, what is not in the plan, and then put some of that things into the plan. Now let's go to the questions, which I usually ask, but hold on one second, one more slide before we go to the questions. I created this picture again to explain to you that, remember we started our course where I told you that there is a management triangle, so-called, where we put the scope, cost, and time into a management triangle and call them the constraints, call them the limits, the borders of what's happening in the project. And then I told you in another lecture that there is also one component which participate in this set of constraints, and this is the quality. So when we do the project, we can do the project having some scope, having some costs, having some time, and having some expectations about the quality. So we, for example, can implement a software module, a product with a low quality, with the same cost, scope, and time constraints as we can implement another product with a high quality. And there will be two different projects with two different results in the end, with a high quality, with a low quality. And remember, the quality is not only about how many bugs we have in the product, but the quality is about all the processes which happen in the project. The quality of coding, the quality of testing, the quality of DevOps, the quality of of many other things, which are which constitute the management. And now I'm telling you that there's one more component which makes this this structure even more complex. The fifth component, which is called risks. So we can do everything according to these four constraints, but we can add one more constraint, and then it's going to be again two different projects. Let's say we do we implement everything paying zero attention to the risks, so just ignoring the uncertainty and saying we don't care what may happen in the future. We just completely accept the potential risk, completely accept the potential troubles which are coming into the future. We just go forward. Or another approach, completely different one, completely different, in completely different position of these two extremes, when we either accept all the risks or we completely deal with them. So we decide to take care about every possible uncertainty, and we completely protect us from everything that may happen wrong. For example, we are saying, what if the server gets broken? What if the programmer quits the team? What if this technology doesn't work? What if this piece of code is going to be broken? So we pay attention to all these if, all the multiple ifs, and there could be hundreds of them, or thousands of them, or maybe tens of thousands of them. And we really care about every one of them. So it's going to be completely two projects. The first one is super risky. The second one is super safe. And depending on our attitude to risk, depending on our so-called it's called risk. I think the right term is risk tolerance. So how tolerant we are to the risks, how much risk we can accept. So are we ready to accept? Are we ready to be super tolerant and say, like I said, we don't care. We just don't pay too much attention, or instead we need to pay a lot of attention. So it's going to be two different approaches, and it depends on your requirements coming from the customer. So the customer may demand you to be super so-called risk, as they call it, let's say risk tolerant, or intolerant. So you may be risk intolerant, so you absolutely not ready to take chances, or you okay, because the customer doesn't care. The customer just wants to get the product done, and if you meet some problems in the middle of the, like while you're going there, then they will deal with that later. They just say, don't pay too much attention upfront. We'll deal with that problem later. So that's need to understand. So there are 5 ingredients of the management. It's not a rectangle anymore. I think it's a pentagon. That's the right name for it. And now the questions. Take your pencils and start writing the answers. Question number 1. You just found out that one of your key programmers posted his resume on a job board. What do you do immediately? So you're the project manager in your team. Somebody just started to look for a new job, and he didn't tell you about that. So what do you do as a project manager? First, you do nothing. Second, you update risk list. 3, post a vacation. So you know, okay, this guy is going to quit. So I start finding another person before we lose this guy. Option 4, you offer him a raise. So you just meet with this guy and say, how about I give you more money because I feel that you're not so happy. So what do you do? What's your response as a good project manager? Option 2, what is the cost of a risk? If probability is 0.8 and impact is 0.7 and effect is 1,000 pounds. That question is maybe not good for you now because you maybe don't know, most probably you don't know what is the probability, what is the impact, and what is the effect. You may not know what is the value of the numbers, but still try to think of the cost of the risk. So we're interested in this. What is the cost of a risk? So it means how much trouble will that risk uh, bring to the project? What is the size of the risk? What's the financial size of the trouble which the risk may cause? So pick the number you think is more appropriate. We'll discuss it later. Next question, what is the name of a risk with negative value of the impact? Again, a question which may not be, which you may not be prepared for, but think about it. If the value of the impact is something that the risk is causing to the project, so the impact is negative. So what is it? An opportunity, a residual risk, a threat, or a secondary risk? You may not know this terminology so far, so pick the best answer you think is the best. Another answer. So most of these questions in this lecture will confuse you at the beginning, but we need to dance around them in order to give you the in order to structure the discussion, in order to give you this knowledge I'm trying to give. So what is the relation of elements in the cause risk effect format? So there is a cause risk effect format which we're going to discuss later, and in this format there is some relationship between the elements. So we have cause, risk, and effect. Three elements. So what is it? Many, one, many, 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 one, one, or one, one, one. So it's one cause, one risk, one effect, or many risks, many causes, one risk, one effect. So you got the idea. So pick the answer. Another question. At a technical meeting, a programmer says, I think the use of this framework will lead to problems in the future. What do you answer? So there's the technical meeting going on, and the programmer just predicts that there will be problems if we use this particular framework. So we're trying to make the wrong decision, and a programmer is telling you about that. So that will lead to problems in the future. So now probably everything will work fine if we choose this framework, but in the future there will be trouble. So what is your answer in this case? First option, be positive. Negativity is not welcome here. That's possible answer. Second one, can we prevent them? So you're asking this programmer, okay, we are looking into the problems in the future, and can we do something to make them not happen in the future? And then the option number 3, let's use another one. So okay, you're saying this framework will cause problems. Okay, we're gonna use another one. Let's change our decision. And then option 4, you ask him how big are the problems? What are we looking for? What's the cost of the risk or something? Question 6, a new architect replaces the previous one. So you have a team, and in this team, one architect just left, not one, but the architect left the team, and another architect just joins, and there is serious security flaw in the system. So something is wrong with the security, and that's a flaw means that the system can be corrupted and the data may be lost. So what do you do? And this is the information the architect brings to the table. So he tells you about that. He replaced the architect and he comes to you and says, that's what we have. So first option, you ask him to fix immediately because it's a security flaw. Then you ask him, the option 2, you ask him not to disclose this information to anyone. Just keep it quiet. Don't tell anyone. We'll think about it. Option 3, ask him to estimate the risk of the attack. What's going to be the cost? So let's say, okay, we have the security flaw. Let's say it happens. Then what next? What if they break in? How much data they will steal, or how much damage they can cause? Or you do nothing. You just ignore this information. Option 7, the estimated duration of the project is 20 months. Estimated. So you think according to this cost, time, and the budget constraints, you already made a calculation that there is a 20 months in the future and the project is finished. All the tasks will be finished and everything will complete. But there is a risk as 3x9. So 3 means probability and 9 means impact. We're going to discuss that a bit later. it exists, and this risk, and the risk is about that a few key engineers may leave the company soon, so you're going to lose the big chunk of your team. If this happens, the project will be delayed by another 15 months. So if people quit, you're going to have not 20 months, but you have 20 plus 15. So it's going to be 35 months instead of 20, because people need to be new people need to be hired, new people need to be trained. So it's going to be a long process. So what project duration you should report now to your customer? So the customer comes to you and says, okay, how soon you will finish the project? And your answer is what? 20 months? Or even, you see, even the option 20 months is not here. So you say maybe 20 plus 15 multiplied by 0.3, or you 20 plus 15 multiplied by 0.3 plus 10, or maybe it's 15 plus multiplied by 0.3 multiplied by 0.9, or maybe you just summarize 20 and 15 and you say 35. Maybe I forgot to put another answer here. Maybe you can just say 20, but you now realize that this is not the right answer. So you need to do something with this information about these 15 months, which potentially may extend the schedule of the project. So the question is, what do you do with it? So do you just accumulate, just summarize these two numbers, or maybe you do some calculation? And we'll discuss it. Maybe you don't know the answer now, but again, pick the one you think is the most appropriate. And the final question, there is a risk that the server will break. So you have a server, it's certain it works now. If this happens, the server with the product, a new one will cost another $5,000. So you will have to buy another server and spend $5,000. How do you prepare the customer for this? So you know that there's a possibility that $5,000 may be required for the project, to complete, and there is this probability, it's possibility that servers they break. So you need to deliver this information somehow to the customer. So the option number one, you ask him to pay 5,000 upfront and then refund later. So you just say, you know what, give us 5,000, I'll keep it on the account when the project is complete, and I didn't need this 5,000, I'll just transfer the money back to you. That's one option. Another one, put 5,000 into contingency reserve, so-called contingency. That's right, contingency reserve. Or you put this 5,000 into management reserve. So these are two things which are, the titles on the budget which we show to the customer. Or you put 2.5 into project budget. Again, you may not know the meaning of these two words. Just again, just give the answer you think is the most appropriate. So, did I confuse you with all those words? I think I did, but that's necessary because this risk management actually is full of new terms and you need to understand them. They're not so difficult. So yeah, lots of confusion. I understand that. So these terms, they're not so complicated. So don't expect complex math in here. It's very easy, but still you need to understand the words. So let's start. I'll teach you. It's really simple, much more simple than many other disciplines that you studied. So, question one, you just found out that one of your key programmers posted a resume on a job board. So you know right now that there is a risk. You just did so-called risk identification. So you just found out that there is something new, some new uncertainty, some new unknown, some new thing which may happen. So the risk in general, risk is something that may happen. Many people confuse risks with problems. So let's say already the guy quit the team. He already quit, so you don't have that person in the team right now, and you need to deal with this problem right now. It's not a risk anymore. It's a problem. So the risk is problem which hasn't happened yet, and maybe it will not happen. So he just posted an ad on a job board. It doesn't mean he will quit the company. It doesn't mean he will find a better job. Maybe he just did it for fun, in order to take a look at what are the options on the market. So he will have a few interviews and he will continue to work in your company. So it's not a problem yet. It's a possibility to get into a problem. And your job as a project manager is to make a risk list in front of you, which you work with. And risk list is a list of 1,057 many risks, where you say what may happen in this risk list. You identify what may happen and what may lead to problems. So your job as a project manager, and first step in the risk management, is to identify all the possible risks. And that's the most creative part of the risk management job. Most creative, because you need to make a brainstorming session for that. You need to make a you need to study the maybe literature. You need to be very creative in order to find out what may go wrong. And while doing this, you need to be quite destructive, and you need to be quite negative about your project. So you need to think about all the possible negative scenarios which may happen. Like, some people may get sick, some people may even die, some technologies and the servers, they may just get corrupted, some data may be lost, some money may be lost. So all the potential, we may break some law, and then somebody will go to jail, or we will have to pay some huge penalty to the government. All of these risks, they need to be listed down. And most people consider this activity of risk identification very disturbing to the team, to the project. And I can tell you one story. When I joined one project in Europe, that was maybe, I don't know, 7 years ago, and the project, I was the architect, so I just joined it. But the project was really working with the production platform where the money were transferred. So the people were paying, tons of people, like thousands every day, they were paying money using their credit cards through this platform, and they're getting some service from the platform. And I joined it, and I saw how they manage this business is very immature, it's very unprofessional. I started with risk identification. So I just opened the Excel spreadsheet, and I started writing down what may go wrong with our technology. So I said, we have just 5 servers, but the probability of shutting down the hosting platform is very high. So we just have one hosting provider. So this hosting provider can easily run out of electricity or whatever. So that's a risk. Another risk we have in the team, we have a few people who really understand the core of this software, and these people, they may quit, and we're going to lose the entire human labor. We can lose the entire knowledge about our system. So then, long story short, I presented this list to the management. So I came to that was like maybe the second week of my work there. So I came to the CTO of the company and said, look, this is the list. And there was like 40 risks, like 40 different things which I identified. And then I did the analysis of them, which I will tell you now how to do it. And he said, don't show this to anyone. Just thank you very much for your work. So send me the file and delete it on your computer. Just get back to your work. Just get back to code writing. So don't do this analysis anymore. So people, the management, they're really scared to see the truth. They're really scared to see the future and analyze this potential threats. But if you are a professional project manager, you have to do that. You have to have this risk list in your laptop for any project you do. If you do the serious project, if you do, of course, some small development of some software, you don't care about that. But as long as the project is a bit larger and it involves more stakeholders than just you and your computer, then you need a risk list. So first step is risk identification. So probably in this case, well, the best answer is, I believe, this one. Because if you are a professional project manager, this would be already, well, that would, okay, maybe I'm wrong here. Maybe the best answer is this one: update risk list. So you already, as a project manager, should have this line in a risk list. So you should have predicted this. Your risk list already contains the line which says Jeffrey may quit. The possibility of this was low, because in this risk list, let's say this is our risk list, and each line in the risk must look like this. Let's say it's a number, the ID of the risk, I don't know, 42, and then you say Jeff may quit. This is the description of the list. What is the probability of this? The probability between 0 and 9. So the probability of this was, he was so happy, Jeffrey. We were friends, so the probability was probably, I don't know, 2. This is called probability. And then what is going to be the impact? Again, between 0 and 9. So the impact which will be if Jeffrey quits, he's not an architect, he's not a senior developer, he's just junior developer who is fixing just small amount of code. So we're not going to suffer too much. So the impact will be, let's say, 4. So that's called impact. Probability and impact. We multiply them, and then we get the risk score. I think the risk, yeah, I think that's the right name. So here we have 8, and this is score. I may be a little bit wrong about the names, but it doesn't matter. You get the idea. So you multiply them, and that is going to be from 0 to, as you can imagine, to 81. So this is the score of the risk. And when you know that Jeffrey just posted the information on the job board, what do? You go to the risk list and you update this, the probability that he will quit. It's not 2 anymore. It's 7. The score is not 8 anymore. It's 28. And as you can imagine, then you sort this risk list by this column. This one. So you sort it by the score column, and the risk, which was staying at the bottom of the table, just jumps up. And you start paying attention to this risk. But that happens later. So your part of the risk identification is finished here. It's not really identification, it's also risk identification plus risk quality analysis. They call it quality analysis. So when you deal with these two numbers, you deal with the risk quality analysis. So you analyze what is the quality of the risk. The quality of the risk may be low, so we don't care about this risk, or it's very high. So in this case, not the quality, but yeah, the quality, but not in the sense like the quality, how good is the risk. But there's just two analysis, quantitative analysis and qualitative analysis. So when we do quantitative, we talk about dollars. We talk about another part of this. I'll show you later. But when we do qualitative analysis, we just deal with these two numbers. So these 7 and 4, we just dance with them and correct which one is more relevant to the situation. So now it's 7, 4, and then the risk goes up in the list, and then you've done about this part of the job. Then you go to risk response planning. So now you think what to do with this risk. When you start thinking about what to do, then you pay attention to the risks which stay on top of your list. So nothing is probably not a good option, but in most cases, if you're a really good project manager, then you would predict this. You would predict that the probability was not 2. You would already talk to Jeff. You would already know that the probability was not number 2. The probability was already quite high, maybe 7, maybe 6, because you did this risk identification earlier. So you didn't need this particular event that you saw it on the job board in order to update this number. But then probably for some, that's a utopian situation. So the real situation, it happens here. You update the risk list when you see the reality is changing. So nothing is wrong so far, no problems so far, but you know that the score of your risks must be recalculated. So this is post-evacation. This is okay, and this is okay. These two options are all right, but they happen only after update the risk. So these are the two options which are two possible responses to the risk. So when you see this table, there are two other columns in a very primitive approach. Another one is called fallback plan. No, that's right. Response, sorry. First you say response plan, and then fallback. So response plan, you plan these two things in a very primitive. And more complex risk management is more complex than just response and fallback. They have a little bit more extended set of potential actions. But in a primitive way, this is response and fallback. Response means what can we do now before the risk turns into a problem? So how can we prevent this? How can we mitigate the risk? How can we prevent it from happening? So this one, offer him a raise. This one goes into response planning. So we offer him a raise. We don't even need to talk to him about this vacation situation or about the resume he posted. So we just say, how about we give you a raise, Jeffrey? We love you so much. And Jeffrey will say, wow, thank you very much. And then you check the resume job board and you see that the CV is not there anymore. So you responded to the risk. So you decided what to do. First, you did the identification. You changed the number 7 to 4. You set it to 28, and you put here raise his salary. That was your response plan. You may have multiple response plans. So for one risk, you may have different response plans, many different responses, how to prevent the risk from happening. And fallback is what do we do if actually it becomes a problem? And if it becomes a problem, then we probably go into here and then we say, okay, if he quits, then we go for hire somebody else. So these are two things which you can do before the risk happens and after it happens. Okay, and one more thing about the cost we will discuss now. So the cost of the risk is actually these two plans, 1 and 2, they have the price. So they're not for free. For example, raise the salary, it means give more money. So that means pay money. So in order to prevent this from happening, you need to take money from the project budget and put it into increasing the salary of Jeffrey. But if you would ignore this risk, let's say you don't do any risk management, then you just ignore it. And then when Jeffrey quits, then he quits. So you didn't invest, in this case, you don't invest any money into risk prevention, into risk, dealing with the risks before they happen. So if we put here, for example, we give him a raise for $100. So the cost of this risk, you can imagine, is this multiplied by this. It's 0.28 multiplied by 100. So this is the cost of the risk. Why this is the cost? Because oh no, sorry, I totally messed this up. So the $100 is how much we're gonna pay if we want the risk to not happen. So in order to calculate the so-called cost of the risk, we multiply this 100 by the probability. No, my fault again. Sorry. Totally confusing you. So this is 100. That's right. This is 100. So we pay 100 in order to raise him. Here, there's another cost. Let's say he quits. He just goes out of the company. So in this case, the cost, the damage, we will suffer from, is going to be, I don't know, $500, because we will need to hire somebody else, and this somebody else will work for he will do nothing during the let's say 1 month. He will get on track. He will learn how to try to write code, how to replace Jeffrey. So the cost of the damage is 500. The cost of the prevention is 100. So the cost of the risk is 500 multiplied by the probability. So that's going to be $350. So this is how much damage we're expecting. This is how much money we need to ask from the customer. So we don't ask from the customer 500, because we don't need, because if you look at the entire risk list, you will see many fallback plans. You will see many situations, like the responses to the damages, the value of the damage which our risk may cause. And we cannot just ask all this money from the customer. It's going to be too much, because not all risks may actually happen. There is a probability of happening, and here the probability is 70%. So 70% is that means that if for one particular risk, it doesn't give us very accurate information. Like 70% it may happen. So we can't really break this number into pieces, because 350 is not going to help us. If we have 350 in our pocket, and then Jeffrey doesn't quit, then we will finish the project with $350. That's okay, we saved the money. But if Jeffrey will quit, this 350 is not going to help us, because we will not be able to hire a new person and give this person the proper time to prepare for coding. So 350 looks like an incomplete solution. But on an overall scale, if you look at the entire risk list and you have 100 risks, and for all the risks we have these fallback plans with the numbers, and then you multiply each of them to the probability, then you get a total number. The total number which you can add to the budget and ask the customer for this money. So you will just come to the customer and say, our calculation of how much money we will need using the current team and using the current prediction is $10,000. Plus, we need another $5,000. This is our so-called contingency reserve. So this is the reserve which we need to keep on the bank account in case one of the risks actually materialize. And the customer will ask you, why $5,000? And you show the customer the risk list and you show we have this amount of risks and they have the probabilities. And we calculated the risk, the cost of if what they happen, how much money we will have to spend. So this overall, the summary, then the total number is 5,000. That's a reasonable request to the customer. Not just coming to the customer and saying, yeah, 10,000 is okay, but how about you give us 50% more? In this case, the customer will understand that you're just asking for more money with no justification. But if you do risk management, then this justification will be right on the table. The customer will understand why $5,000. There's a question from one of you. What if the programmer is crucial to the project? For example, this programmer doesn't know, the programmer knows the project from the beginning and the project is huge. Then in this case, the amount of damage here will be not 5,000, but maybe $50,000. And that's a huge damage. And in this case, the customer you will come to the customer and say, you know, our current budget is 10,000, but we ask you not for 10,000, we ask you for 45,000. And the customer will, why another 35,000 on top? And then we says, because this programmer may quit, and that will mean the project will be completely ruined. We're going to lose the entire knowledge and we will have to completely start from scratch. Then the customer will say, okay, maybe you can do some response. Maybe you can somehow prevent this from happening. And then the customer will pick. So you come to the customer with a full risk list, and the customer will say how huge some of the risks are, how huge are the consequences, and he will tell you, like, look, remove these risks. So mitigate this risk number 7, number 5, and number 42. So these 3 risks, because they are the most expensive, the biggest damage they can cause. So invest into mitigating them, invest into removing them from the risk list. And then you just go for these plans. You just go for raising the salary to the person or doing something else. So it depends on each situation, depends on how you can get rid of these risks. So some of the risks you accept, and then you say, okay, we understand they may happen, just be prepared for them and prepare the money. And for some risks, you avoid them. So you remove them from the risk list by fighting first, by making the first move before the risk happens. So the question is, what is the final formula for asking money? Okay, that's a good question. We'll get to this final formula in a few questions. But now I hope you got the idea how risk management works. So we have a spreadsheet. We put all the risks there. We identify them. So we know what may happen. We identify the potential events that may happen. Then we do quality analysis. So we qualify them. Not quality, qualify them. Maybe that's proper English word here. So we qualify what's the probability, what's the impact, probability, impact, the 2 numbers. Then we multiply the numbers and see the score. Then we sort the list. And then when we sort the list, we start paying attention to the top, to the top part of the table. So we don't want to deal. Usually we don't want to deal with the entire table because it's going to be huge. It's going to be too long. And some risks which they have very low probability. For example, there is a huge risk. Well, there is a risk of earthquake, and the entire building will be collapsed and the entire team will die. Is it a risk? Yes, it is a risk. It may happen. Yeah, all of us will get just destroyed the entire team will be destroyed because of the earthquake. It happens actually in the world, on this planet. We saw these situations, and not just once. And but the probability of this, for example, somewhere in Moscow or somewhere in London, for example, is extremely low. So in this case, the probability will be 0.001, but not 0. It's still some number. We put it there. We put it on this spreadsheet, and then the impact will be 9. So the huge impact. But then you multiply the probability and the impact, and the score will be reasonably low. So this risk will just drop down at the bottom of the table, and you can just completely ignore it. But the risk which will go to the top of the table, you start writing response and fallback plans. But usually you start with the fallback. So what happens if it happens? What do we do if this risk materializes? And then you put the response plans with the numbers. So this is called quantitative analysis, when you put real numbers, quantity. So how big are these risks? What's the cost of them? So you put numbers, and you see the biggest numbers. And then when you find out which numbers are the biggest, then you try to do some response planning. So you start mitigating them and saying, these are 5 risks which are the most expensive. Let's get rid of them. That's it. That's the entire risk management. Nothing else. I just explained you the entire process of risk management. Now we can go into the details so you can do more fine-tune this mechanism. But overall, you should get the idea. So now I'm asking you the question, what is the cost of risk if probability is 0.8 and impact is 0.7 and effect means the fallback, like the cost of to survive, how much we're going to pay if this risk happens, so how much we're going to pay in the damage. So what's going to be the damage? So we will have to restore the situation from the failure. So now you know how to calculate. We just take the effect, we take the probability and multiply. 0.8, we multiply by 1000. So the right answer is here. 8,000. This is the cost of the risk. Nothing fancy, but you need to know the formula. So impact is not participating in this formula. You just care about the probability and the effect. Probability, cause, effect. So probability, the effect is the price you pay when Jeffrey quits. The next one. What is the name of a risk with a negative value of the impact? Imagine the risk. The probability is, I'll tell you another story, which I didn't mention before. So in this risk list, there could be lines which are talking about positive effect, about positive things which may happen. For example, let's say we are doing the software development and we're making some product, and we say, and this product is open source. So we just keep it online and on GitHub, and we say, is it possible that tomorrow a group of programmers from out of nowhere will just join this GitHub project and will solve the majority of the problems which we are working on right now? So they will just start contributing for free into the project. And we, instead of having the project complete in 7 months, we'll just complete it in 1 month, because we will get a human labor from outside, because they will love our project, because they will love what we're doing. They will just come from different countries, different places, and will start committing their code, and we will just be super happy, and the project will finish in 1 month instead of 8 months. Is it possible? Yes. What do we say? Probability of this situation. Probability is 0.0001 maybe, because usually it doesn't happen. What is going to be the impact? The impact is going to be not, well, the impact will be huge, but it's not going to be 9, it's going to be -9. So we are having not the negative effect, but the positive effect. So in this case, what's going to be the cost of this, the effect of this? How much it will affect us? The effect is going to be 7 months. 7 months minus. So if you calculate the 7 months reduction, 7 months, like -7 months, I would say, 7 months reduction of the schedule. Or maybe if something similar may happen with the money. For example, you're doing something, and what is the probability that you will get a huge donation from an anonymous sponsor? You're doing something interesting on GitHub, it's open source, and then somebody will just appear of nowhere and give you $1 million to support what you're doing. Is it possible? It is possible. It happens sometimes, but it's very unusual type of event. So, and there could be some other things, but not so unusual. So there could be things which actually may happen, that actually may help the project. For example, you're saying that, for example, we may imagine the situation where you again develop the software, and there is another guy who works right now in another company, and this guy may join your team. So you want this guy to come to your team and work with you. So not Jeffrey leaving your company, but Jeffrey joining your company. It's also a risk. It also goes into the risk list, but with a negative sign, because it's not a risk anymore. It is an opportunity. So we call it opportunity. The risks and opportunities, they go into the same spreadsheet, and they stay into the same list. And they also get sorted the same way we get sorted when we sort the list. But when you sort them, you will see the top. On the top, you will see the risks, the top risk. At the bottom, you will see the top opportunities, which will drop down because of the negative values of the impact. And then you also measure how much is going to be the effect of these opportunities, and you also pay attention to the most interesting ones, to the most valuable in the multiplication of the effect multiplied by the probability. So in this case, the probability is going to be that the cost of this is going to be extremely small. So it's going to be very low probability, even though 7 months is here, which is a huge gain on the time. But if you multiply by the probability, it's going to be the value is going to be like 1 hour or something, or 1 day. So you just ignore it. But if you see the interesting value there, the interesting cost of the risk, then you start provoking this to happen. So you see there's an opportunity and you think, what can I do to bring this Jeffrey into the company faster? So how can I accelerate the opportunity? How can I mitigate the risk, and how can I accelerate the opportunity? How can I provoke it to happen faster? And then you think about response plan to these risks, to this opportunity. So maybe we can, I don't know, meet with Jeffrey a few more times and tell him about our project. That's your response to the opportunity. Or maybe we can, I don't know, maybe we can, I don't know what you can do to get Jeffrey on board, but you do something. You invest some time into this. You invest some money into this. Why do you do this? Do you do this? Because you saw your risk list. Because you, in the morning, you just come to the office as a project manager, you open your risk list and you do it every morning, and you see, okay, what do I do in order to mitigate more risks? What do I do in order to accelerate more opportunities? That's all. That's how you deal with uncertainty into the future. That's how you make yourself more comfortable with your fear of the future. And we all are afraid of the future. We all are scared of what's going to happen. In order to decrease this fear, in order to decrease your tremble about what's going to happen, you do risk management. And not only related to projects, you can do it for your personal life. This risk management is very well applicable to personal, like to things which happen to you in personal life. You're, for example, a student. So make this risk list for yourself and draw down what may happen to you. Like you may be, you may not pass the exam. Is it a risk? Yes. You may not pass this exam, that exam, that exam. You may fail this work, that work, that work. You may fail to pay for something. You may have some financial problems. You write it down on the risk list. And then you do qualitative analysis. So analyze what may happen faster, what will give you the biggest damage. Then you sort this information, and then you see what's the top priority. Deal with these top priority things. And again, look at other threats, look at other thing. So risk basically is, this one is equal to risk. Threat and risk is the same name. So what is residual risk and secondary risk? So residual risk is the risk which we ignore on this table. Just like I told you, we have a huge table. We sorted the primary risks. They go, not the primary, but the top risks. They go on the top of the table. The rest of the table we ignore. We call them residual risk. So they are later. We'll take care about this later. We're not interested right now. That's okay. So usually people pay attention to 10, maybe 20 risks on top of the table. Usually 10, maybe even less. If the project is huge, if you're like developing a multi-million-dollar project, then your top risks will be, of course, more than 10, 20. But your residual risks will be extremely huge list. Hundreds or maybe thousands of risks. They're all different kind, but you just ignore them. And secondary risk is what happens when we implement the fallback plan or the response plan. So let's say we know that Jeffrey may quit the company, and we know there is a risk, and we know that in order to prevent this from happening, we need to raise the salary of Jeffrey. But if we raise the salary of Jeffrey, there is another risk coming, that everybody else in the team will just understand what happened and they will start asking for a raise, or they may quit because they realize that what we're doing, we're just trying to keep Jeffrey on board by just giving them more money. So there's this secondary risk, maybe even bigger than the risk we had before. So in a good project, in a good risk management, we need to identify these secondary risks and put them also on this spreadsheet somehow. So say that this is the response risk, the response plan, but pay attention, just another column where we say secondary risks. Actually, this risk management is not really suitable for the spreadsheet format, because as we're going to see very soon, it's not very tabular information. So it's not like risk, only the qualitative and only the probability and impact columns, they fit for the table, and maybe the score. But then for each risk we may have a number of response plans, we may have a number of fallback plans, and for each response plan we may have a number of secondary risks. So you can imagine how it will look on a spreadsheet, how uncomfortable it will be to deal with this if you just have a spreadsheet management software. So that's why people created the software for risk management, and you can find those software on the market, specifically for risk management, where you do this identification, you do the analysis, they just calculate everything for you and show you the ultimate picture of how risky is your life, or how much threat is coming, or how much damage you should be prepared for, and how can you prevent these things from happening. What is the relation between of elements in the cause risk effect format? This is exactly what I was saying. So this is not just plain, this is definitely not true. This is not true. So it's not like cause risk effect. And let me explain a little bit about this format. So cause risk effect, this is how people recommend, and I strongly recommend, to write down the description of the risk. So we shouldn't just write Jeffrey may quit. This is not a proper description of the text of the risk. It should consist of three parts. First, we say Jeffrey is underpaid. So we know his salary is not so big. Then we say Jeffrey may quit. And then we say knowledge will be, okay, it's too complicated, not the knowledge. The release will be delayed. So this is cause. This is risk. And this is effect. And if you write it in one sentence, it will read like this. Because Jeffrey is underpaid, Jeffrey may quit, which will lead to the release, not delay. The release, and in this case, the release will be delayed. So it's one sentence which you put together and put it into the description of the risk. Why this structure is better? Because for one cause, you may identify a number of risks. For example, Jeffrey is underpaid. What it leads us to? He may quit. He may uh, change the mood of the team. He may go around the team and tell them stories that he's very well underpaid, and because of this, the blah 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 blah. So he may negatively affect the mood of the team. He may I don't know what else may happen, but there could be other risks. So the risk, so when we say cause, we always use the present tense. Jeff is. So we just say what is right now. This is the reality. So when we formulate the risk, we say from the reality which we observe now, there is a possibility to move to the future like this. And then if this jump to the future will happen, then this is what happened in the future. So we say Jeffrey may quit. So this is may. In the description of the risk, we always say may. You cannot say Jeffrey already quit, or because in this case it's going to be the problem, not the risk. So every time you describe the risk, you say may. That's the key word for the description of the risk, which many people misunderstand. It's definitely need to be there. Jeffrey is underpaid. Jeffrey may quit, and this is will be. It should be will be. It's very necessary. Is, may, will be. There are three important syntactic components of the description of the risk. So, and again, for one cause, there could be multiple risks. For one risk, there could be multiple effects. So Jeffrey may quit, which will lead to what? To delay of release, to, I don't know, loss of knowledge. Maybe he may steal something from us. He may take some other people with him. So we may lose other people, lose others, because he will go to another company. So he may try to take other people from the team. So for one risk, for one cause, it could be multiple risks. And for one risk, there could be multiple effects. And what's interesting is that one risk may have a number of causes. For example, Jeffrey is underpaid and the market is very demanding right now. So these are two causes of one risk that Jeffrey may quit. If we just take one cause, for example, Jeffrey is underpaid, but there is no other positions on the market right now. So on the market, we have no other options. Let's say, for example, we work in a very small town. And in this town, Jeffrey lives with his family, with the parents, with the wife, with the kids, and he's underpaid. But in this small town, there are no other software companies. So there is no risk in this case that Jeffrey will quit, even though underpaid. Or maybe the risk is extremely low probability because he has no options to where to go. So there is no market. So we're saying that the risk of Jeffrey quitting may have cause number one and cause number two. They may be connected like this. So the right answer is many, many, many. So many causes, many risks, many effects. That's the matrix which we can connect. So the best risk identification, I'm leading to my conclusion. So the best mechanism of risk identification is first to identify all causes in one list. Then look at these causes and identify what risks may happen, looking at the causes. And then try to identify the effects. And basically there is these three lists of causes, of risks, on the effects. They will have some interconnections between them. And then each interconnection will lead to a new risk. So you identify this cause, this risk, and this effect. This is risk 17. This cause, this risk, this effect. This is risk 43. And so on and so forth. So you identify this, you connect these three components, and you say risk 1, risk 2, risk 3, and write them down as a list. That's the idea of. That's one of the approaches to risk identification. There could be other approaches, but I find this one the most effective. At a technical meeting, a programmer says, "I think the use of this framework will lead to problems in the future." So the programmer predicts the future for you. The programmer basically did the risk identification for you. He says, I know that from this reality, that the cause, we use this framework, the risk, we may have problems. We don't know the effect. So we have first component, second component, we don't know what it leads to, but he says there will be problems. So let's say we have three components together. We use the framework, we may have problems, in the effect, problems. So what do we do with this? This is about our reaction to the list. So first first option we may ignore. This is called ignore, or people say accept. Ignore or accept. That means we don't care. So we just put this information into the list of residual risks, as I told you, just at the bottom of the table. Thank you very much. But even this response is not good because here we didn't put it to anywhere. We just say, please be positive. So this be positive is completely unprofessional. So professional risk management is about negativity. So we want to be negative about the future. We don't want to be positive. Looking positively in the future, it's good for poets and I don't know, songwriters. But for project managers, for risk managers, we're looking into the future with a negative, with a negativity. So we should be skeptical. We should be not negative in an emotional way. So we're not just get depressed by knowing all the risks, but we are trying to identify as many unknowns, as many uncertain events into the future in order to be more certain, in order to be more prepared for what's coming. So this answer number one is absolutely unprofessional. We don't do this, even though we can do it like technically. So we can say to this person, thanks for telling us this. We just wrote it down. I put it at the bottom of the list. Later, we'll get back to this question. I will probably come to you and ask you, what problems do you mean? What exactly may happen? Try me to identify the probability. Try to identify for me the impact. So help me to do the quantitative and qualitative analysis of the risk. Option number two, can we prevent them? So you already know about this. So this is called mitigation. So can we do something so that this happens, that this doesn't happen, preventing them? Option number three, okay, let's use another one. So in this case, it's called risk, I think it's avoidance. Again, I may be a little bit messed up with the terms, But in this case, we just completely, instead of even mitigating them, so we just take the framework and then start dealing with the risk. We completely remove the cause of the risk. So we remove, you remember the cause. So we use the framework. Because of this, we may have the problem. Because of this, the problems will happen. So we just remove the cause of the effect. We fight with this. We just eliminate the cause. And here you ask the person, okay, what are the problems? So help me to identify what are the problems. And in this case, more probably you will do the fold. You will deal with the fallback plan. So you want to build to prepare for what's coming. So what is the best answer? I think in this case, that depends on your attitude to risks, but it seems to be that this one is the proper answer. So you want to know what the problems, because before you can make these decisions, you need to know what you have. For example, he's telling you that will lead to problems. What problems? I will not be able to find another job. That's the answer from the programmer. So if you use now this framework, it means that I will not have the opportunity in this project to learn the framework which I wanted to learn. And that framework which I expected to learn is good for another company which I'm planning to go to in 6 months. So these are the problems. There are problems for him, but not really big problems for the project. So in this case, we just do nothing. In this case, we just ignore this risk. So we need to know what problems before we start dealing with the risk. Before we start planning the response, we need to build this line into the risk list: probability, impact, score, the cost of the consequences, and the cost of response. And then we make a reasonable decision. Next question. A new architect replaces the previous one and tells you that there is a security flaw in the system. So you had the architect, there was a security flaw as well, and the new one tells you that that he just discovered this security flaw. What do? Ask him to fix it immediately. Ask him to not disclose this information. Ask him to estimate the risk of attack. Well, probably if you are a good project manager and you were doing professional risk management, then probably your answer is this, because you should already know about this. So you already should have asked your previous architect to analyze all the security flaws, and he should have told you about this before. But of course, it's definitely utopia, especially when we deal with the serious security flaws. So probably there is no chance that the previous architect knew about that and just ignored the situation. But this is the best. This is the closest answer to the best. So maybe the best one is here. So you ask him to estimate the risk of attack. So again, you don't make any decisions, for example, like this one, ask to fix or ask him to not disclose. Both decisions are okay, but only after you know what's coming, only after you know the future, only after not only you know the future of this particular attack, but when you put the situation into the context, when you put it into the risk list, and then you analyze it together in combination with all other risks. Maybe you have bigger risks there. Maybe you need to spend your time and your money into fixing something else. And that decision was already made in the risk list. So just by looking at one particular problem and reacting to this problem before it goes into the risk list and before it goes through the quantitative and qualitative analysis of the risk and response planning, it's unprofessional. So first we send it through risk list, record it down, do the analysis, and only then we decide what to do. So this is an example, a good example of so-called reactive management. Reactive. And we don't want to do reactive management. When you react, there is a problem, there is a risk, we react immediately. We want to do proactive management. Proactive management is when you proactively think about what's coming, you prepare for that, and when it comes, you already prepared, you already taken all the measures against this situation. So we don't want to be reactive managers. The estimated duration of the project is 20 months. There is a risk. Now you know the numbers. So what is 3, what is 9? This is probability, and this is the impact, right? So we know now we have the information. 3, so it's not very high probability, and there is quite high impact. So few key engineers may leave the company soon. So it may happen, but maybe 30% probability. But if it happens, it's a huge damage. If this happens, the project will be delayed by another 15 months. What is this? This is the effect of the project, or as we say, the damage, or it will say the fallback plan, the cost of the fallback plan. So 15 months means that we will have to work another 15 months. So this is the cost of the fallback plan. So if this happens, we start doing something which costs us 15 months. So now the question is, what project duration you should report now to the customer? So now you probably know already. So we take the probability, we multiply by the effect, and we add it to the already existing estimate. So it's 20 by 15 plus 15 multiplied to 0.3. So this is your duration which you report to the customer. If you have just one risk, I'm saying. So of course it's not going to happen. You're not going to have just one risk. You will have many risks in the risk list. So you do this calculation with every element on the risk list, and then you put all the pieces together, summarize all of them, and then go to the customer and say, we're not going to be able to complete it in 20 months. We will do it in 47.3 months. And the customer will say, how do you know it's going to be 47.3? You will say, well, 20 from here is, look at our Gantt chart. Look at our decomposition of the task. Look at the time estimate we put on every task. This is 20 months. Okay, the customer will say, okay, how did you calculate 27.3 on top of that? You say, well, look at our risk list. We have 70 risks identified. We pay attention to the top risks, which are 12 of them. So for these 12 of them, we identified the probability and the impact. Then we calculated the cost of the fallback, and then we summarized, and we know that this is what's going to happen. The customer says, no, it's unacceptable. This is too long for me because I want to do it in maximum 29 months. Then you say, all right, then it's going to cost you more. Why? Because for each risk, we have a response plan which will help us to eliminate the risk from the table. And the customer will say, okay, how much? And you say, well, give us another $1 million, and these risks will be eliminated, and then we will, well, not guarantee, but our estimate will be 29 months. That's a reasonable conversation with the customer. That's a professional management. So you're not just expecting or saying to the customer, we're afraid of that. We don't know what's going to happen. This project is super risky. This project is super uncertain. So give us as much money as you have. The customer is not going to like it. But this attitude, this calculation, which I just demonstrated to you, is going to be definitely convincing. So this, unprofessional managers do this sometimes. They just look at just 15 months. Okay, it may happen. Okay, let's add it to the schedule. Let's add the money to the total cost of the project. Let's just put everything there and then ask this money from the customer. This is not how you want it to do. And then final question, like you asked in the beginning. So how should we calculate the total budget? And I see you have one question which is quite relevant. You're asking, shouldn't we deliver 3 points estimate for this question? 3 points estimates, they go into time management and they go into cost management. So when we were estimating this 20 months, how did we build the estimate of 20 months? We were asking programmers how much it would take for you to complete this task, how much to complete that task. They were delivering us 3-point estimates. So let's say they told us, the programmers, they told us that together. So let's say we have a list of tasks. So we have task 1, task 2, let's say 3 tasks in total. And then we asked our programmers how much it's going to take. They gave us the best case, the worst case, and the most possible case, most likely, how much it will take. So they gave us the numbers that for task 1, it's going to be 7 months. It's going to be, the worst case is going to be 40 months. Most likely it's going to be 12 months. He said for the second task, the same programmer. So this is programmer number 1. And then programmer number 2, also programmer number 3, they also gave us the same spreadsheet. So we put like 3, I don't know, 17, 4. And then 15, I don't know, worst case, 47 and then 19, something like this. So we took this estimate from one programmer and the same estimate from another programmer, the same estimate from the programmer's three. Then we just get it together into some average. And then after the multiplication and calculation, we come up with the number 20. So we said, okay, this is the estimate of the project, 20 months. And then we start risk analysis. So that is the estimate which is coming from time management, from the time management area. So here we estimate the time, but we were dealing with certainty. Well, of course, there's also some uncertainty involved. You may say that worst case, best case, people deal with uncertainty, so they don't know exactly what. But this is the part where we still come up in the end with a fixed estimate, with a fixed number. And on top of that, we start dealing with things which are completely uncertain, like risks. And they allow us to increase, to put the buffer on top of the fixed evaluation of, and on a fixed estimate, on a fixed prediction of the future. So time, cost, and scope analysis, time, cost, and scope estimates, they go before risk analysis. So let me show on this final question. Just answering your question. There is a risk that the server will break. If this happens, a new one will cost another $5,000. How to prepare the customer for this? Ask him to pay $5,000 upfront and refund later. This is completely immature. You probably already understand, because the customer will be very surprised that you're trying to play the role of a bank. So just give us as much money as you can, and then at some situation, at some point, you're gonna spend my money. So I'll be very concerned as a customer, and it will be very difficult to explain to the customer why 5,000. Why? Because it's not just one server. You will need this for every risk, and there will be tons of this. Different situations. So you will have to ask a big amount of money up front. It's unreasonable. So definitely not a good answer. These three options are possible. Each of them are possible. Let me explain you how you structure the budget. How do you put pieces together? So first you do cost estimate. If we're talking about money, like before I told you in the previous example, I showed you this best case, worst case, and whatever, that's the time estimate, but something similar with the cost estimate. So this is the first component which you calculated. Let's say your cost estimate is $500. On top of this, you put so-called contingency reserve. So this contingency reserve is what's coming from the risk list. Remember, we summarize all the fallback plans, the cost of the fallback plans multiplied by probability. And you get another, I don't know, $400. It's called contingency. So this is coming from your work breakdown structure, where you have all the work needs to be done. So it's already needs to be done. You're already sure. This is the certainty. This is absolutely for a fact that this needs to be done. So this money must be on a bank account. We cannot continue without them because we must spend them. This money, we don't need to spend them. We think potentially we spend zero. Potentially this contingency reserve will be kept on the bank account, and when the project is finished, we just return back this money to the customer. So this is the reserve. This is why the name, contingency reserve. So we ask the customer, according to our risk analysis, we need $400 as a reserve. If one of the risks happen, we have the money to cover the consequences, to pay for the damage. And then on top of that, people put so-called management reserve. Management reserve. And this is management reserve, which usually constitute like 20% of the entire of this cost estimate. Oh, it's just some fixed amount of money which people pay, which they call it. Why it's called management reserve? Because usually this is what the project manager deals with, like you are, and this is what your boss can put on top of that. And also the PM box says that this part, contingency reserve, is for known unknowns. Known, like we know about them. Unknowns mean risks. And this part, management reserve, is for unknowns. So something which we don't know which will happen, and we don't even know what may happen. So we did proper risk analysis. We analyzed all the possible unknowns, all the possible uncertainty, all the events which may happen, and we calculated the total and put it into contingency reserve. So our cost is 400 on top of that. And plus we asked the customer, give us another $150, a management reserve. So here, for something which we absolutely have no idea what may happen, the earthquake, whatever, we just didn't even predict that. So usually this is what's going on to the customer, this structure. So you show this calculation and present it to the customer, and the customer will decide. The customer may say, you know what, that's too much, so forget it. When something big happens, when something bad happens, you just come to me, I'll give you the money. It is maybe acceptable, but not really comfortable for the team. So if you work like that, you may end up in the situation where the project is at risk. In order to continue, you need some money, but it will take time to get this money from the customer, and because of that, you put a lot of things at risk. So better to predict this, prevent this from happening. So the right answer here, so you can put 5,000. So here we deal with what? There is a risk. So definitely it's not management reserve. So we know a risk. We definitely already identified the risk. It's a known unknown. It's a known risk. So now we have to choose between these two options. You put 5,000 into contingency reserve, contingency reserve here, or you put half of this money into project budget. Here it doesn't say where, but I believe it's also gonna go here or maybe there. But this answer is not right, because how did you make a decision about dividing it half? So why 2.5? Why not 3,000? Why not 4,000? So this decision is absolutely unjustified by any information in the question. So nobody told us that the probability of this risk is 50%. So that's why it's not an answer. So the right answer is here. You put 5,000 into contingency reserve. Well, you may say here that in this case we have a probability equals to 1. And we discussed in the beginning of the lecture that if the probability is 1, it's not a risk anymore. It's a problem. So when the probability, well, if you move the probability from 0 to 1 to 2, 3 to 0.1, 0.3, and then up to 0.9, at the point of at the point when it equals to 1, or maybe 10, if you do it on a scale from 0 to 9, then if the probability gets so high, then it's not reasonable anymore to say that it is a risk. While the question is, there is a risk that the server will break if this happens, and so on and so forth. So maybe this answer is not really so perfect with the 5,000. So maybe I was wrong. Maybe more reasonable actually this question, assuming that the probability of this risk is 5. Because yeah, maybe this answer is not good, because if this would be 5,000, then the question would not say the word risk. The question would say, it is a problem. The server is already broken. So how do we put 5,000 how do we ask the customer to give us 5,000? Then 5,000 goes into the budget. So I believe this answer is, you see, I'm arguing with myself. Okay, we are more or less finished. Let me answer a few of your questions. Where to get money if I see the team is going too over the budget? What should I say to the client? No risk happened, just a big mistake by developer while estimating. But maybe this is a risk. Yes, you're definitely right. This is a risk. It's also a possibility. It's also a possible problem which may happen. So when you estimate everything, you look at your estimate and you scratch your head and think, well, maybe I made a mistake. Maybe my people underestimated the complexity of the work. And you write it down into your risk list and say, well, it may happen that we will work for a few months and realize that we made a mistake in the project estimate. Then we do the proper analysis of this risk. What's the probability of this to happen? And then you look at the fallback. So what's going to happen if this happens? The project will fail. We will just run out of money, and it's a huge compromise it will hugely compromise our future. So we need to do some response planning. Then you sit down and start preparing to do something with it. For example, re-estimate every few days. And try to educate your customer that you're going to re-estimate every few days. It may be one of the response plans. But yeah, you put everything into the risk. Everything that bothers you, everything that makes you nervous, everything that looks to you like a problem in the future, You just write it down in the risk list. That's the recipe for for management, for project management success. I think this is the main recipe, not the proper planning of time, which we discussed before, not the quality management, not the scope management. And actually, this is the what I got from the book from by Rita. So Rita is also saying that everything in project management dances around risk management. So risk management is the core ingredient of project management. If you do it right, you're gonna have more or less get like it's going to be more or less a guarantee that you will get, in the end you will get what you wanted. And the same, my recommendation to you, the same attitude to risk management in your personal life. Just have your own personal risk list where you put all the things that bother you, all the things that may look like scary outcome in the future, and apply the same technique as I told you today, the same technique of very simple qualification and quantification of the risks, and then fallback and response plans, and you will be much safer. So your homework, I suggest to create this, you see this risk register. So actually PMBOK is not using the term risk list, they use risk register, but I find risk list more suitable because it's coming from rational unified process. Maybe you know about it. So rational unified process, they call it risk list, and PMBOK, they say risk register. So create this risk register for your project and try to identify 5 risks. Just do a very small homework. Just create a spreadsheet, identify 5 risks, use the format I suggested: cause, risk, effect. Make sure that you have the proper wording, the proper syntax of how you describe the risk, and then do the qualification of them, then the quantification, and you will see how interesting your future will look for you.